Hello everyone. Welcome to this training session on statistical data analysis using SPSS. My name is Vamsidhar. As a part of this session, I would be taking you through the K-means cluster analysis. We have already looked at a couple of cluster analysis models in our earlier sessions. So we would like to just see how the K-means cluster analysis procedure of SPSS will actually give us a mechanism to group the variables, or sorry, to group the data. Because as we have discussed earlier, the prime intention of any cluster analysis is to assign the cases, assign the data elements to a group, to a specific group. Here in K-means cluster, we are talking about assigning the data to a fixed number of groups. So probably I can say 3 groups or 4 groups, and the prime intention being characteristics. The group's characteristics I don't know. That's the intention of any cluster analysis. The group's characteristics I don't know, but they have to be determined based on a set of variables which I identify. Right? I right now don't know the characteristics of the variables, but based on the data that I have, I want to identify the characteristics, and based on that I want to group my values also. That is where I take the help of K-means cluster analysis. So whenever we are talking about a good cluster analysis, it should use a very few set of clusters. The reason being, if I have 20 groups of data and each group having 10 or 20 elements in each, probably a better targeting, whether it is in terms of understanding the overall profile or even providing customized service. These are some of the prime reasons why someone want to do a cluster analysis. So if I have 3, 4, 5 clusters, it becomes very easy to understand what differentiates cluster 1 from cluster 2 in terms of characteristics. Whereas if I have 20 clusters, literally it becomes very difficult to understand what differentiates one cluster from the other. So it has to capture all the clusters, which is effective. It should be effective means any even if there are 5 or 10 records which are significantly different from the rest of them, the system should be able to capture them, right? So the way it starts off is depending on what I mention as n number of clusters that are required. So assume that I am talking about 3 clusters that are required. What it will take is the SPSS will take K well spaced observations, means the observations which have a decent amount of gap. It takes K such well spaced observations and forms the initial cluster centers. Means this is the mean, this is the center for the first cluster, this is the mean for the second, this is the mean for the third cluster. Now whatever the record 1, the case 1, it will see whether it is closer to this cluster center or closer to this or closer to this. Based on that, it assigns the value to the initial cluster center, to this particular cluster. Once this record is assigned to this cluster, even again the cluster center is recalculated. The cluster center is recalculated, and the same way the procedure iterates until all the elements are identified and associated to each of the clusters. And in some cases, once the cluster mean is updated, it may so happen that there is not too much of a difference between these two clusters. So all these kinds of manipulations and all these kinds of differentiations have to be brought out in an iterative fashion. We'll see in our analysis also how each of the iteration is actually improvising the cluster center and the categorization of the cases to the various groups. So as far as our data is concerned, I would like to look at classifying the records, the whole set of patient or customer data I have. I want to classify them into three fixed number of clusters using the K-means cluster analysis, and based on that try to observe what are the key characteristics of each of them. Alright. So to accomplish that, the better thing is make sure that, I mean, though it's not a mandatory thing, I generally prefer having all the variables standardized. Whatever the values you would like to take as a part of the analysis of the cluster, it's better that you standardize all of them. So what I would like to do is there are some variables which are standardized earlier. I would clear all of them and again start off with the activity saying first I will standardize those variables. How do I standardize them? You could go to any of that descriptive stats procedure which we have used earlier. Select probably all, even if they are nominal or ordinal variables, except for log and all those things. Let's say at least until this arm values, you select all of them and you say save standardized variables. That's nothing more than that, right? If required, probably don't display any of these things, doesn't matter. So for me here the intention is just to standardize the variables. Means I would have got some extra columns here, Z height, Z weight, Z cholesterol. So these are all the standardized values. And if we see here, there would have been some kind of a value computed which are standardized or normalized for each of the variables. Right, so there are for each of the variables we have computed some standardized values including the categorical variables. If we see here the categorical variables, also the gender, the marital status, we have done some kind of standardization even on those variables also. Alright, so now what I can very well do is I can initiate the cluster analysis, the K-means cluster analysis. So I'll go to analyze, classify and talk about K-means cluster. Now whatever are the standardized variables which we have created, I will select all of them. I want the cluster to be created based on all these. Now if you don't want some of them to be included as a part of the creating of the cluster, which means if I don't want the grouping to be done based on some of these fields, you can very well choose it, not an issue at all. So I am just choosing almost all the variables which got created, and probably I am saying I want three clusters. I want three clusters. You can specify how many clusters you want and how many iterations you want to be performed. So by default there is a number 10, because we are using more number of variables. It is possible that it may go through a more number of iterations. So I am just mentioning as 25 to be the maximum number of iterations. So you can very well increase it also. If at all even after 25 iterations the system is not stable, you can very well ask it to increase the number of iterations also. And even I am choosing the options part, wherein I would like to look at the ANOVA table and also the cluster information for each case. I would like to see whether each of the case goes into cluster 1, cluster 2 or cluster 3. And it's better, of course we don't have too much of missing values, but even if we have, it's better to go with exclude the cases pairwise rather than list wise. Okay, I'm doing a continue. Now this is where in case we want the cluster centers to be our own, I can very well specify these things here. Otherwise, by default, it will take the cluster centers by assigning some very heavily spaced kind of variables it will identify, and based on that, it will identify the cluster centers accordingly. Now, if I look at this analysis, yeah, initial cluster centers. If you see, they are, it has taken well spaced observations. It has taken some well spaced observations, and it has created the initial cluster center. So 0.87 is the Z score of the height, whereas minus 0.7. So these could be the people with lesser heights. This could be the people with a better height, more heights, and probably these could be even more shorter people. Similarly, if you look at it with respect to weights, this is a group of very heavy weight people, right? The weights are much higher, whereas the weights are moderate, whereas the weights are much lower. So this is the way the grouping initial cluster centers were created. You could see that here it is close to -1, means the negative, wherein we have taken on the lower side, which is the males, and the other two are the groups corresponding to the females. Some such kind of initial cluster centers. Age wise also you could see this is a cluster with very elderly people, moderately elderly people, and probably youngsters. Right? Similarly, when you are looking at Z score with the weight, we could see these are low waist people, then probably these could be moderate waist, these could be high waist kind of people. So all these kinds of categorizations here also, if we look at it, so smoking status, it is showing these are the people with almost never smoking kind of status, somewhere moderate, whereas heavy smoking kind of status. So we have different sets of groups created like this as a part of the initial cluster. So initial cluster is not of much importance for us because it used some kind of a basis of k well spaced observations, and using that well spaced observations it has tried to compute the initial values. But look at the iteration part, it is showing the progress of each cluster at each step. Initially, there is a huge difference. The progress of each of the clusters, what you are seeing in the initial stages, the cluster centers are shifting much faster. At least in the first iteration, 4.7, 4.4, there is a big shift in the cluster centers across. But the moment you touch, let's say, the 6th or 7th or even the 10th, by the time you reach the 12th, it is completely converged. So even a small, not even a small change is occurring in the cluster center. So it has stopped the iterations by the 12th. But probably if we see, even after the 9th or even after the 10th, the cluster centers stopped shifting that drastically. So if at all it has not converged after even 25 iterations, I would have suggested that we increase the number of clusters also. So here we could see that this is the way the system has executed the 12 clusters, and based 12 iterations, and the change in the cluster centers are observed in this manner. Now getting into the actual analysis part, you could see that the cluster membership wise, it is saying case 1 is categorized to third cluster, something like that. For each case, it has identified the cluster, right, as well as the distance. So you could have clearly seen for all the 400 cases, it has identified to which cluster do they really belong to, characteristics wise to which cluster do they belong to, and probably when you are looking at the ANOVA table, this is what is the table wherein it will tell you which variables are contributing very heavily to your cluster. which variable. So if I write it, in case of the ANOVA table, right, let me write this. In case of ANOVA table, it will tell me which variable contributes more to the cluster solution. This is what you should analyze from the ANOVA table. And how do I analyze which one contributes more to the cluster solution? Look at the F values. In your output, look at the F values. Whichever variables are having very large F values, they provide a very good amount of separation between the various clusters. So probably 385 for gender. So gender provides a very good separation, right? I can very well say that gender provides a very good separation, because we are seeing that the F values are very high for gender, and probably the next is with respect to weights. We are seeing a significant difference in the weights across the various cluster groups, whereas probably the cholesterol levels are not that great across the various cluster groups. Even the pulse rates are not extremely different across the various cluster groups, and marital statuses are not that different across the three groups. Education levels are not that significant. Only probably gender is very significant. Then probably the Z scores. Though on a real significant basis, all of them are having a significant values, but the most important thing for us to look at is which of these values they provide very good separation between the clusters. So here I could see those 3-4 variables provide, or even waist size provides a very good separation between the clusters. The arm provides a decent separation. The BMI provides a decent separation between the clusters, whereas things like cholesterol, things like pulse rate, they are not providing that great separation again between the clusters. So then again, if I come back to see the final clusters, this is what is the characteristics of each of the clusters. Initially, it has started with some cluster center, but after a continuous iteration, probably after 12 iterations, these are the final cluster centers that are computed. That is the mean of each of the clusters based on the values belonging to each of the clusters. The system will compute the corresponding mean, and this is what is a reflection of the characteristics of each of the clusters. So let's see with respect to the weights. This is a cluster containing low weight people. This is a cluster with a moderate weight, whereas the cluster 2 is having a high weight, right? Whereas when it comes to gender, we are seeing cluster 1 contains significantly on females, whereas cluster 3 contains significantly males. Cluster 2 contains both the categories. And similarly, if I am looking at the waist, cluster 2 contains a very high waist, cluster 1 contains very low waist, and cluster 3 a moderate waist. Whereas if I am looking at the BMI, cluster 2 contains very high BMI, very low BMI for cluster 1, and moderate BMI for cluster 3. So some way I should be able to say the cluster 2 majorly contains both males and females, were predominantly dominated by the males again, wherein are probably males and females, because this is predominantly dominated by females, this is predominantly dominated by the males. But whatever it is, we are seeing the cluster 2 typically to contain very high weight, very heavy weight, and probably very heavy waist size, high BMIs, and even a high arm diameters. All these are the key characteristics of the cluster 2, whereas in the cluster 1 you are seeing almost all of them to be negative. So they are all on the lower side, whether it is age, youngsters, probably with respect to the waist, the ones which are having very low waist, but these are the ones who have moderate pulse rate, but coming to the BP, they have much lesser values, BMI much lesser. Probably you can consider that these set of people are more fit kind of people, whereas on the other side in cluster 2 I am seeing a different kind of a solution altogether. So cluster 2 also I could look at, cluster 3 also I could look at, and the more important thing, okay, how good are my clusters? If I have to look at that, it's better to look at from the distances between the final clusters. This is what actually is computed as Euclidean distance. Again, there are formulas for that. So there is a Euclidean distance that is computed, and if you see that the distances are very high, we see that the clusters have great dissimilarities. So here the distances are not that great. So what you could probably one way of looking at is there is a good distance between cluster 1 and cluster 2, whereas cluster 3 wise, if you see, it is more or less equidistant between cluster 2 and cluster 1. So there is a significant difference between cluster 1 and cluster 2, but not that between cluster 3 and cluster 1, as well as cluster 2 and cluster 3. Right, if the number of clusters increase, even the problem could be much more aggravated also. Now if you see the number of records in each of the ones, in cluster 1 we have 137 records, in cluster 2 we have 92, and in cluster 3 we have 171 kind of records. So probably did we save those clusters just to see? No, we did not save those. So probably what I should do is I go to this the same Kmeans cluster, and under the save, it's better that I go with the cluster membership as well as the distance from the clusters, right? Because that will tell me to what I mean. Probably that save will actually save my values here. You come back to your data, you see that the cluster membership for each one of the variables is saved. Along with that, the distance of each of the record from the cluster center is what is clearly identified. Now what I could very well use is, based on this distances, I could even view the box plot to see if there is any kind of significant misclassification that has occurred. Now that I know the distances of each of the cases from the corresponding cluster center, now I can very well look at if there is any kind of significant misclassification that has occurred. So what I can do for that is I go to the graphs. I can probably bring out the chart. So I'll go to the chart builder. I'll go to this chart builder and bring out a box plot. Okay, I'll bring out a box plot. So I can drag a simple box plot. This I think is a simple box plot. So I'll drag this onto this canvas, and so I'll look at the distances now. Probably because we have saved the distances now, what I'll try to drag is I'll drag the distances of the cases. I'll pull them here, the distances of the cases. and the cluster number I'll pull it onto the x-axis. So just to see how the cluster number is actually different clusters, what is the kind of variability of the data that we have in each of the clusters. So what I could really notice here is, yeah, the variability. So it is actually helping us to identify the outliers within each of the clusters. Here what you could see is, in cluster 2, we have a few records 302, 342, 335, and 375, which are slightly outliers. But when it comes to, but not extreme values, we don't have too many extreme values. There is a variability wise also, we are not able to see too much of big difference in the variability across the three clusters, but three or four values are slightly outliers in case of cluster 2, and two values are outliers in case of cluster 3. So what we could also, if the variables are too much, if the number of records are too much misclassified, then probably it's an issue. Then we should rework on probably increasing the number of clusters or decreasing the number of clusters, because the cluster solution whatever we have got is not that effective. So that's the way we can use the k-means cluster analysis to group your records. So typically, just to summarize the process, what we should do is, whatever we have done, I have used the k-means cluster analysis. I've used the k-means cluster analysis to group the records. Right, that is what we have done. We have done the grouping of the records into 3 clusters or n number of clusters I can use, especially in case of customer segmentation. In case of customer segmentation, if I know I need 5 different groupings of the customers, because I would like to assign 5 different managers to my 5 groups, and I want to allot my customers to each of the groups based on a specific identification done by the system based on the various characteristics. So we have gone to a customer segmentation for doing any kind of grouping of the records or classification of the records. I can use the cluster analysis. If at all we find that the 3 cluster solution was not that good, I can look out for a 4 cluster and 5 cluster kind of solution. And how do I identify whether this solution is better compared to a 3 cluster solution? One, look at the distances between the clusters. If the distances between the cluster centers is very high, then probably the groupings are more appropriate, but otherwise there may not be a goodness in the grouping. Two, look out for outliers. Once you plot a kind of a box plot, look out for outliers in the cluster. Right, box plot, you can very well use the box plot, look out for the outliers. If you find more number of outliers and extreme values, then it's an indication that your cluster is not a proper cluster. So probably you should get a better solution by increasing or decreasing the number of clusters. So there is no way you can identify what is the best number of clusters. Probably you have an automated solution 3, 4, 5. If something can be automated, you can even arrive at the best number of clusters, but the simple way for us to look at using the k-means cluster analysis is run it with a different set of clusters. right? Run it using the different set of clusters to typically come out, different number of clusters to typically arrive at what would be the better combination, what would be the better number of clusters for this particular data. I hope I'm able to explain the concept of K-means cluster analysis comfortably for you. If you have any further queries regarding the same, I suggest that you get back to me on the number that I have given below, and or even you can send in an email at vamsidhar@facegurus.com. I can very well get back to you with the necessary clarifications to your queries. Thanks a lot for listening to this session. Thank you very much.